Séparation Webb Space Telescope. Go Webb!
Fantastic pictures of this telescope.
Go Webb, go Webb!
Yes, go Webb.
When we look at the stars in the night sky, we are looking back in time, since the light entering our eyes from these distant objects set off years, decades, or millennia earlier. Unfortunately, we do not have a clear view of the stars from Earth, because of the blurring effects of the Earth's atmosphere containing gas and dust particles. In order to avoid the interference of the atmosphere, we need to leave Earth and place the telescopes farther out into space to get a clear view of the universe. In 1990, one of the largest and most versatile space telescopes, the Hubble Space Telescope, was launched into low Earth orbit. Hubble's orbit outside the distortion of the Earth allowed us to capture extremely high-resolution images with substantially lower background light than ground-based telescopes. It has recorded some of the most detailed visible light images, leading to breakthroughs in astrophysics. However, Hubble cannot look too far back into the past as it cannot capture the infrared light. Observing the universe in the infrared is important for a few reasons. One reason is that the light emitted by the very first stars has been stretched by the expansion of the universe. $14 billion years later, when that light reaches us today, it has become infrared light because of its longer wavelengths. Another reason is that stars and planets form in clouds of gas and dust, and this dust obscures our view. Infrared light penetrates these clouds and allows us to see inside. If we had wanted Hubble to see infrared light, we would have needed to cool it to extremely low temperatures. Since Hubble is located only 600 kilometers above Earth, where the telescope heats up with, not only radiation from the Sun, but with the heat reflected from Earth, it is not possible to use Hubble to look too far back into the past. To address this issue, on December 25, 2021, scientists sent out the most sophisticated and complicated telescope ever built, the James Webb Telescope, to a point in space located 1.5 million kilometers away from Earth and 150 million kilometers away from the Sun. After 29 days of journey through space, the James Webb Telescope will arrive at its destination. It will spend the first 100 days cooling itself and 20 more days to finish alignment. It will then spend between 2 and 6 months to calibrate its instruments. After 6 months of preparation, the James Webb Telescope would be ready to take its first picture using primarily infrared light coming from faint and very distant objects. In order to be able to detect those faint signals, the telescope itself must be kept extremely cold, -220 C or lower. That's why the Webb has a 5-layer tennis court-sized sunshield. The shield protects the telescope from the heat of the sun and keeps its instruments cold. Additionally, the telescope will always be on the same side of the sun, Earth, and Moon, so that Earth always casts shadow on it at all times. The telescope will move with Earth in our orbit, so that we could send and receive signals fast and issue time-sensitive commands. There are only 5 points around Earth's orbit where the gravitational forces all add up, so that a satellite always remains in the same relative position to the Sun and Earth. These points are known as the Lagrange points. For the Webb satellite, the L2 Lagrange point is the only one that makes sense, as it is on the away side of the Sun, Earth, and Moon, and located near Earth. James Webb Telescope orbiting around the L2 point will only need a course and altitude correction on timescales of just over 3 weeks. This will minimize the amount of fuel needed to maintain its orbit. This is important because the fuel is the single most limiting factor to Webb's lifetime, as it's required for 4 major purposes: course correction, orbital insertion, orbital corrections, and, finally, for pointing the telescope at distant targets and maintaining its orientation in space. As soon as the Webb runs out of fuel, it will no longer be able to maintain its orbit, and it will no longer be able to point at its targets with the requisite precision. That means, when its fuel is gone, the mission is over. Thus, the telescope is expected to operate only 5 years, whereas the Hubble telescope has been operating for 35 years. However, if we need only minimal course corrections to arrive at and insert the spacecraft into orbit around L2, this will save on fuel use, giving us sufficient fuel for slightly more than 10 years of operations. But we should never bet against the cleverness of NASA's scientists in stretching the limits of what's possible with even antiquated technology. James Webb is the most complicated and expensive space observatory in human history. Its development was so lengthy and expensive that the US House had to cancel its funding in 2011. Though the funding was later restored by the Senate panel. $30 years and $10 billion later, the James Webb Space Telescope is finally on its way to Lagrange Point 2 to answer some of humankind's most interesting questions. Where did we come from? Are we alone in the universe?